Hello, the intention of this video is to understand the Parquet file format succinctly, and we shall be covering these topics: row versus columnar data storage, Parquet format, the benefits of Parquet format with respect to size, performance, and cost comparisons, converting a simple CSV to a Parquet format and see the benefits which we get, visualizing the Parquet file in IntelliJ. Let's get started. The first thing which we wanted to understand is the difference between row and columnar storage. So if this is the data which we want to store, then how can it be stored in a row-based storage? In row-based storage, the data in a row is stored together. The row-based data is co-located. We can see for the row ID 1, then row ID 2, all the data is co-located. Vis-a-vis in a columnar storage, what happens is the column-based data is co-located. So we can see here that this data, if we see the employee ID data is co-located here. So we are seeing employee ID and this 10, 12, 13, this is the employee ID data. Then we see the other column, which is the last name column. The data is co-located here. So we can see that in the column based, it is like column based organization of data which has been done. The first benefit is compression, which means in a column based data, we are able to apply compression more easily and we are able to reap more benefits out of compression. So let's see it with an example. So we have this data, which is a column based data, which is stored together in a column based data store, columnar data store. The data is co-located. So then we have more opportunities. When like data is stored together, the opportunities, the algorithms for compressions are applicable more nicely. So that's where compression possibilities are more. And let's see a very simple example. A very simple and naive compression could be that for this Jonas is repeating twice. We store the Jonas only once and we put the row IDs separated by comma. This is one of the examples of a simplistic compression which can be done. Vis-a-vis in a column based data, all the data is stored together. So the possibility distinct and discrete data is stored together, and that's where the possibility of compression is less. So the first big benefit is compression. The second main benefit is the query time, the performance of the query. So if we see here, let's say that I have to select all the employees whose salary is more than 80k, more than or equal to 80k. So these are the employees who are eligible for this. So I want to select the employee ID. So in the case of row based data, if in case the indexes are not in place, I have to iterate through all the rows and find out where the salary is more than 80k or equal to 80k. So I have to iterate through this data, the number of rows are there. I have to iterate through all the rows which are there. uh, Vis-a-vis in a column storage, what would happen is the first query which we will do is here. So we would be able to find out all those rows IDs where the 80k is the salary. So this one 80k plus is the salary, and this one. So we are able to see that 003 and 002 are the eligible ones, and then we go here and we iterate through this. So uh, our query is based only on two columns here in this example. So thereby we get a very enhanced performance because we are able to restrict our query. So if in case there are, let's say, 100 columns and we have to fetch the data only from 3 columns. So in a row based storage, you have to still go through all the columns which are there because you have to iterate through individual rows, and thereby the query performance would be very less. Here you have to iterate through only the queries where the applicable data is stored. So you already get the benefits of index if in case you are having a column based data storage. So these are the listing of the benefits which are there. Some of them we have already seen. So this is data stored row wise, data stored column wise, access pattern. So this row based data is more for transactional workload where you have to delete, update, modify, those kind of thing. For analytical queries, columnar data is more suited because the query is more faster and you are able to analyze the data more efficiently. So this is more beneficial for read and write kind of operations. This is for analytical queries where we have to do aggregations like sum, average, those kind of things which we have to do, and we have to perform the operations on the subset of columns. Then it is very, very useful when we have subset of columns where we want to operate on. This is very effective compression. So size would be reduced greatly if in case we are using columnar database compared to the row based database. Schema evolution. So if in case schema is changing, so if the schema changes, meaning you have one more column to accommodate, it is easier to do that in the row based storage. Column based storage can also support schema evolution, but is more rigid compared to row based storage. Usage, we already discussed, it is more suited for OLTP kind of loads, and it is more for analytical OLAP kind of loads. And these are some of the examples. We are going to see Parquet in detail going further. So what is Parquet? So Parquet is a columnar storage file format that is designed to be highly efficient for use with big data processing framework. It is an open source project that is part of Apache Arrow project. So we, what are the features of this Parquet format? First thing is Parquet stores data in columnar format. This we already know what exactly the improvements we get once we have a columnar storage. Compression would be very efficient. Parquet supports various compression algorithms like Snappy, gzip, and others, and it significantly reduces the size required for storing the data, thereby saving the space on the hard disk. Plus data transfer would also be very efficient and very fast. Schema evolution. So Parquet is designed to support schema evolution. So if in case you are adding or removing columns, Parquet supports that. It's a flexible with respect to schema. Performance. The columnar storage and compression characteristics of Parquet made it well suited for analytical processing. It allows for more efficient data access and improved query performance. And cross-platform compatibility. This we already know that it is designed to be language agnostic and supports multiple programming language. Thereby, it is cross-platform compatible. So, what are the benefits of this Parquet format? So, this is one of the statistics which has been presented. This is a link from where I have taken it. I have not performed this myself, but let's see what are the details which it is giving us. So, it is saying that if there is a 1 terabyte CSV file, when you convert it into a Parquet format, the size becomes 130 GB. We will see this in the example which we are going to see, like a 87% saving when using Parquet. Now what happens is query runtime. So this person executed some queries and he saw significant decrease in the query execution time. From 236 seconds, it went to 6 seconds. So 34 times faster. When the data was scanned for querying, this scanning was performed in the whole data set, wherein in the case of the Parquet, it was only a subset of the data which was scanned. So 99% less data scanned. So this depends on the kind of query you are executing. So probably the data of interest was within few columns, and thereby we saw a lot of improvement in the scanning of the data. Now the cost. So if you execute a query, you have to pay the cost to the cloud provider or where exactly you are running your load. So for example, Google or Amazon will charge with respect to how much data is stored and with respect to the amount of data scanned per query. So the cost becomes significantly less if in case we are storing the data in Parquet format.
So this is a simple Python program. The intention of this program is to convert a CSV file to a Parquet format. Let's go through the program. So the prerequisite is pandas and pyarrow. You can do a pip install on pandas and pyarrow to get them installed. Then you get the file, you read the file in a data frame, and you give the name for the Parquet output file, and you can say data frame dot to Parquet, and you have to provide the engine as pyarrow. Okay, and this is the simple 4 5 lines of code by which you can convert your CSV file to the Parquet format. Let's see this in action. So I have placed the program here. This is the program and this is the file which I want to convert. Okay. And the same file name was there in my program as well. And let's run this program now. So the conversion has been done. So we can see the content of the file now. We can see that a 6.6 MB file, okay, that has become a 151 KB file. So this is such a significant, such a tremendous amount of benefit which we have got by doing this conversion.
So how can we visualize the data on the Parquet format? We can visualize in various ways. One of the way is to see it in IntelliJ, which I have represented here. You go to settings, and in the settings you go to plugins, and in the plugins you search for Avro and Parquet viewer, and in the viewer, the viewer you can open by going to view tool windows, Avro and Parquet viewer, and you would be able to see the data. You can drag and drop the file there and see the file contents. I'll show you in a bit.
So I'm going to drag and drop the Parquet file here in the viewer. And once I drag and drop it here, I would be able to see the data. Let's see the data. And this is the same data which was there in the CSV file, and I can see it nicely organized in a viewer. And if we want to see the schema, we can visualize the schema also in this viewer. Thank you very much.